make you better. So, Zach, you had some questions were decent. And I mean, I think I was actually more generous than I probably could have every question was based on 10 points, except for the station model, that was a 5-pointer. So what would a 10-point question, what would the response of a 10-point question be? Look at the values that I gave you. Do you think that they were fair, or do they, in my opinion, I think I gave more than I should have. But what do you think? Zach, what was your strongest question?
I think my strongest question was question 1, but even then, I think when it came to...
Wait, I'm sorry, say that again louder.
My strongest question was the first question, because I think I wrote like the most out of all the questions for that. That was like a page of just writing with like some diagrams to show stability. But I feel like with that whole stability portion, that I could have answered that a little bit better and like used the term buoyancy, because I don't believe...
How many points did I give you for that first question?
I don't have I only have like my version pulled up. I can go pull.
Oh, on Blackboard, you should see the numbers I gave for each one. What do you think? I mean, Lena, you did pretty decent, right? But like ozone, here, you know what? Here, I'm going to show you guys. I'm going to do this. Let's do it this way. How many words could we have written down? Like, give me all the words that we could have written down. Words that I would look for. And so start with a list. We're going to create a list.
Probably like Chapman reaction.
CFCs.
UV.
Say louder, I'm sorry.
UV.
Dynamic equilibrium.
Stratosphere.
Aaron, you got some too? The rest of you keep going.
Aerosols.
Go look at your notes too. I mean,
Greenhouse effect.
no, absolutely not. I should never see that in ozone discussion.
Monatomic oxygen.
I suppose I should see all three of those, right?
Would photo disassociation be one?
Not necessarily the word, but that would be fine. What else?
UV radiation.
Got it up here. That's number 3.
Oh. Infrared radiation.
Not in ozone problems.
Ozone hole.
And what word would I want to put there?
Depletion.
Pollutant.
Breakdown. This is what you said, right? That's not right. Just so. Dissociate. Um, what do you think? How many of those did you have in yours? How were yours in containing all of those things?
Maybe half. I don't know.
Maybe half. Maybe the last two, I wouldn't necessarily go, oh yeah, you're failing. But if you added those, I'd probably go, wow, that's good. So, and if I look at all those words that really need to be there in discussing the ozone problem, all of those words, all of those concepts need to be there. Even if you gave a sentence per, which, I mean, you'd have to at least draw some diagrams or equations or something like that. That's going to be a lot more than what I got from you when I get these little paragraphs, right? So if I really gave you a grade based on, let's even say the number of words, what letter grade or what number out of 10 should you have gotten on this? What would make it better? I mean, do you know what it's like to strive to be great? That's really my question. Do you know what it's like to strive to be great? Do you know what it's like to work to really get stuff? Now, like I said, all of you here, you people right here are very good at being here. If you missed a class, you've been writing some stuff to me. So this has been good, but the question is, can you learn to be better? Or do you not want to be better? I mean, I hope that's not the case, right? Or I'm hoping that maybe you just look at the world and go, I don't know how to be better. I don't know how to do this. So which one is it? Why is it that the stuff that you gave me, despite the plea, comes up short? And again, this is a question. This is not, I'm not chewing you out. I'm not upset. I want to see if we can become better. Can you do that?
Yeah, definitely can learn from this.
Yeah.
I mean, that's my goal. Now, the ozone thing was one thing. Look at the greenhouse effect. That one, not only did some of you not say very much, but what you said was wrong. How many of you in your greenhouse essay wrote the word trap? Or the word block? Or the word reflect? Anybody put those in there? Tim, you did? You put reflect.
Yeah, I put reply.
Do me a favor, give me your sentence with that word in it.
I said the greenhouse effect is when long wave terrestrial radiation from the planet is either absorbed or reflected by greenhouse gases.
Okay, so gases, those gases do not, and there's no reflection. Within the greenhouse effect, there is no reflection.
Okay.
Now, at least in the way that we want to discuss it in terms of the greenhouse gas. Now, did reflection play a role in the diagram that we drew in class? Okay, so that would be dealing with what? What is the reflection indicator? And this is a question for everybody. What does the reflection indicate?
High albedo.
Okay, what's the word, Zach?
Albedo.
Spell?
ALBEDO.
ALBEDO, right? Some of you spelled it. When you said albedo, I think some of you spelled it not good. So we want to make sure that you have, if you're going to deal with albedo, that's a reflection. That's not really the greenhouse effect. I wasn't looking for whether or not there's reflection. But how about when you write a paper, right? In English teacher, I hope to God, English teachers teach you how to write papers. What do they stress is the first thing, the most important thing in any essay? I hope they still do this. If not, then I understand. You guys know what I'm looking for? Okay, Aaron?
Organization.
Organization is great, but when in the paper, what's the most important thing in the paper? Nobody? You've taken English, right? You graduated high school. Sam, what is it?
I want to say explaining.
No, thing. I'm actually thing. I'm not talking. Yes, a paper should be organized. You should explain things. But what's the most important thing in an essay?
Like organization with paragraphs.
No. Do you guys thesis statement? Do you know that term, thesis statement? Here, have you heard, do you know this or do you not know this? Oh, okay. Well, okay. Well, if that's the case, Sam, well, this is a problem in education. Thesis, what is a thesis statement?
Oh, wait, thesis statement. I thought you said something else. Yes, I know what a thesis
Oh, okay,
statement.
okay. So
I thought you said something else. Sorry.
So if you're doing an essay, right? Long answers. This is an essay test. You should have a thesis statement. So right now, write down the thesis statement. Write it to me as a personal message, a personal chat message. That's where I want you to write it. Okay.
For which question?
On the greenhouse effect. Ryan, take a look at that and go. It's incomplete. It's not accurate enough.
On the greenhouse effect, right?
Mhm. Okay, Lena and Julia, I'm seeing what you wrote. I don't know if I would say that is the correct thesis statement you should have. Although, Julia, I understand why you wrote that. Expound on it. Definitely not, Sam.
Yeah,
Greenhouse effect. The greenhouse effect is not a significant problem. That would be
I'm
my,
not the best at
expounding, explaining, getting to level 3. That's why you need to, if you're not the best at it, that's what you have to do.
I wasn't the best I wasn't really good in English classes.
This is not even English class. That is a false statement. How about the rest of you guys? I want you to know this stuff. Aaron, I would say no. You are conflating. You know what I mean by conflating, Aaron? You're putting together two concepts that we separated.
Can you remind me what a
Oh,
thesis
that's
statement
interesting.
is?
That's interesting, Zach. Hold on a sec. Your first sentence is a really interesting sentence, Zach. I'm going to share that in a second. And Julia, now that you've been more precise, don't take this bad. Now I would take off more points because it's not just, it's more precise, but it's more precisely wrong. It is not correct. What do you think, Tim? What do you got? And let me see who else. Isaac, we're still missing yours too.
I sent mine.
Oh, you sent yours? Oh, I saw that. Oh, okay. Okay, so listen. Listen to these. Tim said this. The greenhouse effect, the greenhouse theory is a fact. Okay, I would say that's a problem right there. Theories aren't facts. The
Yeah.
greenhouse effect.
I meant the greenhouse effect is a fact.
Okay. That's fine. So, but listen, so I'll change it. The greenhouse effect is a fact that states that the dynamic process of radiating energy that helps heat up.
The atmosphere. The
Yes,
atmosphere.
okay, that's fine, right? So it's a dynamic process of radiating energy that heats up the atmosphere. Now, Julia said the greenhouse effect is a natural process that warms the Earth's surface by absorbing solar radiation. Zach says the greenhouse effect is the process of using infrared radiation from our sun to warm our atmosphere. All three of those are different and incorrect-ish. Well, incomplete. Tim, yours is more incomplete than incorrect. And this tells me, so Sam, a thesis statement is just a statement of, like a summary statement. You could start this essay with this statement, expound on it, and get an A. And I'm just trying to find what's the best one here. Lena says greenhouse gases are natural and they're not the same thing as global warming. This is true, but adding to them will create negative effects that leads to our Earth's atmosphere changing and the surface of the Earth. Don't say heating as much as warming, but okay. So you've got some ideas in the back, but you're still missing the overall idea. All right, now Isaac is a little bit more detailed. So listen to this. Can you understand it when I'm just talking? Are you able to concentrate enough to hear what I say? The greenhouse effect is a natural process that warms the Earth's surface by absorbing the sun's energy with the greenhouse gases and releasing the energy as infrared light down to the Earth's surface. So what I'm seeing here, Shannon, do you have one?
Yeah, I'm trying to get to it right now.
Your mic is really quiet. If you talked. Did you talk? Shannon,
I'm here, sorry.
do you guys hear her?
Not really.
It's like I can hear you in the distance someplace. All right, so what that shows me, at least, and maybe this is why you're struggling with this, is you are nowhere close to level 3 understanding. How long did we spend on greenhouse effect? At least an hour, right? I mean, we're talking about 2 solid lecture hours. So here's the question then. We need to come up with this thesis statement. But most importantly, you need to understand what the greenhouse effect is. And did we not draw a picture? Do you have a picture that we drew in class? You have that. Can you summarize that picture, which is what I want you to do? Let me do this. So get out that picture. I'm going to see if I can find that picture. Hold on. Fly. Oh, in Otro, that's what I did. Huh? The greenhouse effect and global warming. Get that cycle. But do you agree that there's depth? Shut up. Radiation. Part of the radiation that's okay. There's the diagram. Prove to me you understand this diagram. Like, tell me what it means. You have it. Was it, I don't know, was somebody in the class that they just, as part of the essay, just took a screenshot and put it in their essay? I don't know if it was one of you. It might have been. But again, do you see the problem that would cause? Well, okay, great. You put a good picture in there, but did you explain the picture? And really, it's explaining things that matters. By the way, I am reading that book. I told you a little bit about it. It's called Apocalypse Never by Michael Schellenberg. I don't know if I told you about that book. Oh my gosh, it's brilliant. It is absolutely brilliant. And it makes, I've been thinking so much. I think the biggest problem in our society is we think about issues about an inch deep. Somebody says, oh, this is bad. Plastic straws are bad. And they give it this much thought. And you don't really know what the hell you're saying when you make a statement, plastic straws are bad. And he goes into what that really means in the big world picture. And when he goes through his discussion, now your understanding is deep, not shallow. So do you agree that global climate change is something that you hear about all the flipping time if you pay attention to the world around you?
I just saw an article today about it.
I am ready to explode because, in my opinion, and I'm giving it to you, the media and our politicians' brains are about this thick. They couldn't
Sounds about right.
way out of a paper bag. And I also am going to make my opinion known because I'm getting angrier and angrier, not at you, but just the world in general. It's ironic that the people we listen to the most, who talk the loudest, are celebrities and politicians who know.
Who have little to no
this much.
knowledge.
Unbelievable. I can't even, I'm like, why do we even listen? Why, really? And we're going to use Twitter, which is how many letters in Twitter? And you're going to take a whole concept into this much. And maybe that's why your essays are so bad, because your essays are like a tweet and you're not demonstrating anything. So based on what you've given me in this little thing, you're lucky you got the grade you got. Because it ain't nothing. And we're going to get there with the greenhouse effect. Damn it. because, oh, wait. Oh, yeah. I'm looking at you over here and I'm looking you on my screen and I'm looking at you on my Zoom. And Shannon, you're in two places, or Julia, you're in two places. And Tim, you're wearing a hat and you're not wearing a hat at the same time. I want you to be at least adequate, maybe not a huge mile deep, but I want you to be more than the surface. So what I want you to do right now is write a thesis, like a summary statement, or it can be more than one sentence, of this picture. Would you find it useful to do it independently, or do you want to do breakout rooms where you can piece together what is it that you're going to say as a group that you can share with everybody else? What's better for you? If I were in class, I know what I would do, but you're not in my class. What would you rather do? Isaac, what do you want? Breakout or individual, write down a summary on your own right now for the next 10 minutes?
I don't really have a preference.
Okay, Julia, how about you?
Honestly, breakout rooms. So
You like the breakout rooms? You guys, are you good with breakout rooms? I don't care. You are telling me what to do. So I'm going to pause. Now we're going to start the recording again. You're all back. So who wants to start and read what they're saying? How did you guys do? Shannon and Isaac, did you write something physically down?
Yes.
Can you read it?
Yeah. So we said that the greenhouse effect is a natural energy basis cycle. The basis is that solar shortwave UV radiation is emitted through the Earth's atmosphere into the Earth. It gets absorbed by the Earth's surface. Once it has been absorbed, the Earth begins to emit back towards space in the atmosphere, but is stopped by the greenhouse ozone gases. The gases that absorb and emit the infrared long-wave terrestrial radiation back towards Earth. If the Earth did not have the greenhouse ozone gases, the equilibrium would be reached between the radiation coming in and going out. But since there are greenhouse gases, the equilibrium is thrown off and more radiation is emitted back towards Earth than going outwards towards space.
Okay, so I like a lot of what you said. I would, if I were grading this as an essay, I would go, well, oops, don't say what? Everybody else, what should she not say in there?
Ozone.
Don't say ozone. Because ozone, well, let me ask you this, because I don't want to be the one always teaching you. What you teach each other. What can you tell me about ozone?
Yeah, so I know, I just said it preemptively because I know ozone is a separate gas. It is its own gas. So.
And what does it do?
Also,
and this is anybody, right? What does it do?
Protects us from the deadly.
It does, but in what Shannon said, what would you say in response? What is the ozone doing?
Is it absorbing the sunlight UV radiation?
Oh, okay. See, so in other words, what's coming in? Everybody, you know this. We had a discussion with all of you. What's coming in?
Solar radiation.
Be more specific than solar radiation?
UV.
Shortwave.
Solar shortwave. So you should always say solar shortwave radiation. Now,
Can we say UV?
solar shortwave radiation. What is solar shortwave radiation? Ultraviolet and
Full light.
And what?
A visible light.
Visible light.
well,
Right? This is what you keep forgetting. Now, ultraviolet radiation is shortwave solar radiation. Do you agree with this? But we already know that it's absorbed by ozone. Almost all of it, 98% of that type is absorbed. Where is it absorbed? By the way.
mhm.
Where is it being absorbed?
The ozone
Isn't
layer?
it?
Okay, all right. So Isaac, if you said the ozone layer, I would go, okay, that's acceptable. Could you give me a better word than that?
Is
What's the scientific name of ozone layer?
Stratosphere.
stratosphere?
It is in the stratosphere. That is true. And if you had said that from the beginning, I would have gone, that's fine. But we call the ozone layer something. There was a name for it. We called it the ozonosphere.
Oh,
Isn't a sphere a layer of the atmosphere, like the troposphere and the stratosphere and the mesosphere and the thermosphere? Well, what layer of the atmosphere contains the ozone? The ozone layer is the ozonosphere. Where is the ozone layer? Primarily in the stratosphere. Regardless. Now, other than that, what happens to most of the shortwave radiation as it comes in?
It gets reflected off of the high albedo substances such as clouds. Absorbed.
That is true. It can be, okay, so it can be reflected by high albedo substances such as clouds. Boy, that sounds really intelligent to me. I don't need that in my essay, but if you put that in the essay, I'd probably put a little check mark and I'd write good. If I actually had a piece of paper where I could write that out. But I would say, oh, good. But I don't need that for the greenhouse effect. But yes, that's true. But what's the key thing about dealing with the greenhouse effect is what happens to that, to most of that incoming radiation that's not ultraviolet, shortwave radiation.
Gets absorbed by the Earth itself.
Because what does it do in the atmosphere?
It's transparent, so it passes right
Transparent, passes through,
mhm.
right? Then what? Now the Earth gives off radiation. And what happens to it? Now, Isaac, Shannon, who else was in that first group? Sam, what did I say to you guys specifically? How did we start our discussion? You remember what I said? Imagine.
If there was no atmosphere, I believe is that what you said?
Well, you could imagine no atmosphere. I was imagining no greenhouse gases. Okay, so the radiation comes in, and then what goes back out?
The
The amount that comes in, right? Do you agree? And then that's why Shannon, when she goes, it's a dynamic equilibrium process. Incoming versus outgoing has to balance each other. And whatever comes in is what has to go back out. The only difference between how much, I mean, it's the same amount. The only difference between the two is that the incoming versus the outgoing is a different type. Shortwave, long wave. Infrared is long wave. But I have to give that much. But I don't have a greenhouse gasless atmosphere. I have gases. What gases, by the way?
CO2, methane, argon.
No, what's the third greenhouse gas?
Oh,
Water vapor?
Water
water.
vapor, right? Okay. So those gases absorb it, and then what do those gases do? It puts it back, some of it down to the earth. Some of it goes out, some of it comes back in. So from the perspective of being on the earth, I've got two sources of radiation. The sun, shortwave solar radiation, and the energy that came from the earth is absorbed by the atmosphere and brought back down, which is long wave infrared radiation. I've got two sources of energy. That means I have to get rid of more. Do you agree? I get rid of more by getting warmer. I get warmer. That's the greenhouse effect. So in other words, the greenhouse effect states that the earth is warmer than it would be given its proximity to the sun because gases in the atmosphere absorb and radiate infrared radiation back down to the earth. Isn't that what's in my notes? Don't I have that exact sentence in the notes?
Mhm.
Isn't that the thesis statement that you should have started with? And I've seen some people, they wrote just that. Well, that's still not an essay, but at least that's a good place to start. Always reflect back to the teacher what he says or she says. Now, the reality is, then you have to expound on that. But you did. When Zach, you were reading it, Shannon, when you were reading it, Lena, when you were reading it, all of a sudden you sounded much more intelligent. You sounded like you knew what you were talking about. It's kind of, I mean, do you agree that you have a better understanding of greenhouse effect?
Mhm.
So what is global warming then? And it's pretty simple.
Mm,
Having too much.
Well, what do we increase?
Carbon.
Yeah, I mean, well, yes, but what do we increase? When people talk about global warming, and this is what's such nonsense. Climate change is more than this. This is a part of it. And if you're an atmospheric scientist like I am, climate change means a lot more. But if you're a politician or a celebrity, it usually just means this. It's again, shallow. It means an increase in what?
CO2 in our atmosphere.
mhm.
More CO2 in our atmosphere. Now be a little bit more intelligent. What should you put before? It's an increase of the what of CO2. What's a better word to put in there?
Concentration.
The concentration. So you could say, if I increase the concentration of greenhouse gases, then what will happen? More
Long wave terrestrial radiation is reflected than
no,
naturally.
it is not reflected.
I mean, absorbed. Sorry.
It's absorbed by the atmosphere, and therefore more long wave terrestrial radiation is
Radiated back into the earth.
back to the earth. If more is absorbed, more is going to radiate back into the earth, and the earth's going to get warmer. That's what we're talking about. So in that sense, we're talking about the earth getting warmer because of CO2. Like, we are not saying that CO2 causes global cooling in a global sense. But if the earth were cooling, are there things that could cool the earth?
Mhm.
Sure. What would be the biggest, easiest way to cool the earth? I mean, just for the sake of it.
Mm.
Have more clouds in the sky.
Okay, more clouds in the sky. Because what are you doing with more clouds?
Higher albedo.
Higher albedo. What else could make a higher albedo besides more clouds?
It snows more.
Snows more. Ice, more snow and ice. Could have more, what else? Particulates in the atmosphere, aerosols that could reflect some. Now, do you agree that this is not necessarily a simple if this, then that? Because these are all I'm describing are blanks of the system.
Components.
They are components, but there's a special word for what they do. They sometimes make it colder, sometimes make it warmer. They're all what? What's the word I'm looking for?
What does it start with?
F,
Factor.
not factor. F-E,
Oh, they're feedbacks.
they're feedbacks, right? These are feedback mechanisms. Now there's two types of feedbacks. What are they?
Positive and negative.
Positive and negative feedback. So changing the ice, snow cover, the aerosols, the cloud content, those are all feedbacks. And those are not simple to talk about. Scientists are studying, trying to figure out exactly what those feedbacks will end up doing. But most people can't think to feedbacks because to deal with feedbacks is way down the ocean of understanding. And most people are living up here on this little thin layer.
Mhm.
But do you agree that could change climate? And do you agree that climate change could mean some areas are drier than normal? That's climate. Or wetter, rainier than normal? Maybe there's more extremes. There's a lot of things to deal with climate.
Mhm.
But when you hear global warming, their only thing that they're really concerned about is CO2 in the atmosphere because they want you to stop doing what?
Burning fossil fuels.
Burning fossil fuels. Right? So that's the level that they're talking about. And all we're saying is that if there's more fossil fuels, there's a higher concentration of greenhouse gases. Higher concentration of greenhouse gases means they'll absorb more radiation coming out of the earth, but more radiation being absorbed by the atmosphere will result in more radiation coming back down to the earth. But here's the funny thing. What happens, and let's see if you can be really smart on this one. What would happen if the earth got warmer to the stability of the atmosphere? This is not, I would not have expected this from you. I just want to see if you can figure this out. So imagine that the earth gets warmer. What would happen? Sam, you should be happy about this.
Yeah, I'm just waiting for.
Wouldn't there be less thunderstorms?
Why do you say that?
Mhm.
Because there's less PVE.
Show me what the atmosphere in general would look like with your arm.
So this is okay. When I go like this, it means it's a higher lapse rate.
Is
But-
the lapse rate going to be higher or lower with global
It's gonna
warming?
be lower with a warmer atmosphere, with a warmer Earth.
Really? So take a look at this. In your arm, your elbow's the ground. Which way will your elbow go with the warmer earth? Your elbow. You moved your fingertips. Keep your fingertips the same.
I can't fit my whole arm.
Wouldn't it go more this way? Aren't you your elbow is warmer than your fingertips? Do you guys everybody do that? Make your elbow warmer than your fingertips. That's your lapse rate.
Oh, so
Heat your elbow. Make your elbow warmer. Isn't that a steeper lapse rate? Isn't the greater the lapse rate, the more unstable the atmosphere?
Mhm.
So in general, globally, we might be looking at a more unstable atmosphere. I don't know by how much, but some. And if the atmosphere is more unstable, what would you probably have more of?
More severe thunderstorms.
Well, just more thunderstorms.
more
I mean, maybe
thunder-
more thunderstorms, maybe
I was debating
whatever.
whether I should put severe in there or not.
More thunderstorms, right? So if there's more thunderstorms, that changes things. Would you agree? Will it make it colder or warmer? Is there more albedo, less albedo? I don't know. Those are all feedbacks. I'm not sure how that play with each other,
Wait,
but that changes, doesn't it? So even that simple thing says, oh, there's a complex system where when you change one thing, a whole lot of other crap changes. And we're not that smart to know exactly when everything else changes, what that change is going to look like and how we'll end up. Some people believe that there is a stasis, that the atmosphere is designed to be kind of in this one little Goldilocks zone, and that changing this will result in other things that will keep it from being really bad changes. In other words, it'll get warmer on average, but not necessarily go crazy. It won't be a runaway greenhouse. Maybe there will be worse scenarios. Maybe the positive feedbacks will dominate.
Mhm.
But I'm telling you now, we don't really know all this stuff. That's a lot of knowledge that humanity does not have. We do not.
Yeah, I read something like something about the Earth might start getting warmer until like we hit another ice age or something might happen on this scientific article I read this one time. I'm not quite sure how it works.
Well,
but-
Shannon, it's interesting. There's a thermal haline solution in the Atlantic Ocean. It's haline. Do you know what haline refers to?
Mm-mm.
Salt and temperature changes the density of oceans. And so if oceans, like if warm water rises to the top and it changes the density, it could sink that, and then Europe gets set into another ice age. That's theoretical, right? These are predictions into the future. We don't know. Do you agree that the Earth's climate has changed over millennia?
Mhm.
Right? Is the Earth as warm as it's ever been? I think you
No,
got this
there's like
wrong.
there's been like 2 or 3 other times in its history when it's gotten like really, really hot. When it was
In
like
your last worksheet, I gave you good points for that, but
And a molten rock
Mhm.
in its beginning.
so, there has been times where it has been warmer in the past. So obviously the atmosphere changes, climate change happens, and it wasn't because of us. So something happened to change that. So we don't know all these things, right? There's a high level of, we're not sure.
It just seems like it's on a general trend that it's getting warmer.
Well, you can make
That's
a good
what a
argument.
lot of people are thinking.
It is on a general trend of about 1 degree Celsius warming over the last 150 years. That is true. Then here's a question I would ask. If somebody says that to me, I would say, is that good or bad? Are we living in an optimal temperature? Do you even know how to answer that question
100% we are.
right now?
Yeah.
No, I mean, if it got 1 degree warmer, is that less good or less bad than this?
I wouldn't know.
It depends on some things.
Will it be different? Sure.
Oh,
I mean,
yeah.
it'll be different atmosphere, right? Things are different, but is it better or worse? You understand? To say it's better or worse is a subjective value judgment, right? I don't know. Maybe if it were 2 degrees warmer, things in the earth overall would be better.
Mhm.
I heard a really good discussion. Do you know when people say global climate change is going to tell you that it's going to cost a lot of money? Do you know what they do? They say this. They say this many people in Philadelphia die by heat, and then it's going to be warmer, so more people are going to die, and then a person's life is worth a lot of money, so it's going to cost a lot more. But don't you think over the next 100 years, which I think is silly, but if Philadelphia were as warm as Houston, couldn't we adapt? Are people dying in Houston simply because they live in a warmer environment? No. We do what to our environment?
Adapt and mitigate.
We adapt and mitigate. We adapt to it and we mitigate. We protect ourselves from harm.
Mhm.
That's what we do. So I don't know. I don't know if this is a good temperature or if maybe a degree warmer is better. I don't know. If it changes, I want to be able to adapt to it. So I'm okay with adaptation. I'm okay with protecting people who are vulnerable. I'm okay with that. I'm just not okay with somebody saying, oh, it's getting warmer, we're all going to die. Because that's just nonsense. So if anybody's interested in learning more about that, I really recommend this book. It's phenomenal. I'm really enjoying it. And I've learned a lot because it's been more than just climate change. It's on plastics and manufacturing and poverty, and it's really interesting. So anyway, do you feel better about global warming? Now look at your essay. Could you write that better now? So the difference is you didn't get there before the test. You got there after the test. So now we got to get there before the test. So this whole conversation with me has come about because I looked at the last couple questions on the lab, on the instability lab. And I saw that it was not really well done when I said, and we went over this in class for a long period of time. I said, what happens when you increase the dew point? And then you didn't really give me much. You didn't seem to answer that lab very well, did you? So what I'm going to do is we're going to try to get to this before. So if you turn it in and your answer kind of sucks to those last 2 questions, you might want to turn it in again and hope that Paul will be nice and regrade your stuff and give you a better grade. But why don't we get together in our breakout groups and work on that last couple questions on the stuff. Now, you need to graph it up. Ryan and Zach, I saw that you added the graph when you turned in the second time, which was good, right? What would make a graph better?
Yeah, I realized I didn't like label my axes, so I'll do that when I resubmit it.
Okay, but something else I would say, what's the best way to make a graph better? generally speaking? How about using a ruler?
Yeah.
I mean, that's what I would do. And making sure you're using graph paper so that your lines are straight. I mean, that makes sense. Because you've got to see some information in there. So I'm going to go back to breakout rooms for a few minutes, okay? And you're going to answer that question about the dew point, because we went through this in class, but you haven't shown me that you know this. This is before the test, so let's practice that and get it good. Are we okay with that? Do you see how much I care about teaching you how to become good students? I just want you to be good at it. And I like you so much, and you're all smart enough. There's nobody here who's too dumb to get this. You just haven't done it yet, right? Yoda, do you guys watch Are you Star Wars fans?
Hmm.
How many of you like Star Wars? Thumbs up or thumbs down for Star Wars?
Mm,
Not the
Not the newer ones though.
Aaron, you're a thumbs down for Star Wars?
Yeah.
Julia, what are you?
I've actually never seen it, so I can't really, I don't know.
Who's big thumbs up? Like, who loves Star Wars? Because does your dad, Lena, he watch Star Trek also?
Yeah. So I like Star Trek and Star Wars. I was with both of them.
So you're kind of in that sci-fi. Ryan, what about you? You're a big thumbs up?
Yeah, especially when I was a kid, I loved them.
I just finished season 2 of The Mandalorian. You guys watch that?
I haven't started that yet. I
haven't
have
seen it
Disney
yet.
Plus.
Oh, that's
so I
fun.
haven't started it.
Okay, so anyway, Yoda would say, it's not that you have, there is no try, there is only do or do not, right? People say they try. You either fail or you do it. The problem with it is that a lot of times you guys don't even try. The only way that you should fail is when you fail because you did it wrong. A lot of you go through life and fail because you never try. Right? What did they? Here's a little inspiration. Who invented the light bulb?
Edison.
Thomas Edison, right? Do you know what he had to create? Do you know what the problem was? He had to create a what? What was? He had to create a filament, right? So he has electrical current going through this filament that glows, and he tried like 1,000 different things that didn't work. It would light up and then burn out, and if you got to change the light bulb every 2 minutes, that's not good. He finally found the right one, and somebody asked him, "What was it like to fail so many times before you finally succeeded?" He goes, "I didn't fail. I found 1,000 different ways not to make a light bulb." That was his attitude. Oh, I found ways not to do stuff. And then I found a way to do stuff. And he made a lot of money. He became kind of famous. You guys need to fail because you fail, not because you don't try. But I also don't believe you're going to fail if you do it. You're going to succeed. That's what I'm here for, is to help you succeed. Tim, what were you going to say?
I was going to say, didn't Edison like steal a lot of stuff?
Yeah.
Yeah.
You ever watch The Simpsons?
No, not really.
There was a really funny episode where he was so mad at himself for being nothing in life, and Edison had all these inventions. So Homer he was trying to create inventions. They were pretty hilarious. You'll have to watch that show. Okay, so I'm throwing the breakout rooms. I'm going to pause. Yes, sir.
I'm looking forward to the 10th.
It's going to be lame. Moisture's not there.
Some things are pretty good though.
Nope. Got to watch that Gulf Moisture. Stay with that one. Anyway, what do you guys think? Did you get a good answer? Who's gonna share the work they did with the good answers?
Bye.
Oh, Tim, I wanted to respond. If the Earth is getting warmer, then it wouldn't increase the environmental lapse rate. Yes. No, the environmental lapse rate would increase and the air gets saturated, so there might have more moisture, which means it's easier to get clouds. So you're increasing the dew point globally. So lots of things. I mean, lots of things to consider. A lot of feedbacks. And when we try to answer those questions, we have to model it. And when we're modeling these global situations, we're not very good at a lot of things. Actually, that's one of the big things is we have some ideas, okay, but we don't know the feedbacks very well at all still. Anyway, going back to this, who's going to start with what they got? What do you have? Zach, I know you want to do this because you like to do this.
Yeah, I could attempt. So if we increase the dew point temperature, then that would mean that the parcel of air rising into the air will cause it, will make it so at a lower altitude, it will reach saturation point, and the lapse rate will change from a dry adiabatic lapse rate to a wet adiabatic lapse rate, causing it for a more substantial arc and creating more of a cape.
Are you done or?
I mean, afterwards it would create a larger what's the term? I need to find it. It will create a larger like sin, right? Afterwards, when it's done cross like with its earlier arc, as it returns back to the dry adiabatic lapse rate.
Okay. Anybody else? What else wants to share? That's good. I like some of those things. Who else wants to share? Julia, can you read yours?
Just for number 5, right?
Yeah.
Okay. So we said that the CAPE will be bigger and the PBE will be bigger, and then a lower LCL and LFC. So that like means that there's more moisture in the air, which will lead to more thunderstorms.
Okay. Is that the way you wrote it? So here, Julia, let me just ask you this. Answer truthfully. Did you read me what you wrote, or are you kind of ad-libbing as you're going?
Well, I kind of wrote it in like bullet points.
Oh, okay. Okay. Lena, what's yours?
I have, so in total, the RH is higher, the LCLs are lower, the amount of CAPE grows, which shows the increase in instability. NBE is lower, the ELs are higher, the storm will not be stopped by the cap, and also the dew point depression is smaller.
Theta E is higher too, but we didn't talk about Theta E. Remember that?
Which one was it?
Theta E.
Oh, yeah, I forgot. Oh, yeah, we did have.
Yeah, so all these are good. Now, if I said, put it into an essay about the parcel. So, you know how question number 1 says, so imagine you have a parcel. Tell me everything you know about it. Again, would you agree there's a lot you could write in there? That's really open-ended. Well, what if I said this time, okay, so now we have a parcel with a higher dew point than before. What happens? And you know, you're giving me a list of all these things, but could you make a thesis statement? What's this thesis statement of increasing the dew point?
If when we increase the dew point, it will cause for more instability in the atmosphere.
Okay, I like that. That's pretty decent. Anybody else?
Can you get kind of simple with it and just say increasing the dew point would increase like the chances for a stronger storm, and then umbrella under that?
I could accept that.
Okay.
I mean, that, as a thesis statement goes, right? I mean, you can be different. You don't have to be the same. Shannon, go ahead.
Yeah, wouldn't it just affect basically everything else about the instability? So.
Wouldn't it affect everything else? Well, actually,
Almost
damn.
like-
I mean, that's kind of a good thesis statement. By changing the dew point, there's a hell of a lot of changes that happen in the atmosphere. That's not a bad way to start a paragraph. I know you don't want to be this way because you want to sound intelligent, but you actually are more correct by speaking simply. So I like that. Tim, what about you, bud?
I really liked what Zach said.
It was good stuff. Here's kind of the way I think about it. All in all, instability is a race to get cold between the environment and the parcel that we want the environment to win. Do you agree with that statement? That's a good statement, right? So what is this? Increasing the dew point is changing what? It's changing the parcel. Bottom line is, we need to slow the parcel from cooling. And the best way to do that is to get it saturated.
It's like
Go ahead.
giving the parcel steroids in a race.
Totally. By giving it a dew point, you're increasing its moisture content. By increasing its moisture content, W, right, which is what moisture content is, you're saying it'll saturate earlier. That's the LCO. It's more because it's going to be exponentially related to temperature. With how much heat we get out of it, we're heating the parcel exponentially more than it is when it's a lower dew point. We could say that in the race to get cold, we get it saturated and we're going to win that race. The environment's much more likely to do that. So what does it mean to be more unstable? It means thunderstorms with less cap, less convective inhibition, more cape, stronger thunderstorms, more severe thunderstorms, taller thunderstorms. All of those things are kind of working. So that would be a way of kind of discussing how important the dew point is. Now, increasing the temperature does some of those things. Making it warmer, because we said that, right? Here's your lapse rate. Making it warmer is going to steepen the lapse rate. And that changes the environment's rate of cooling. The dew point changes the parcel's rate of cooling.
So like you could show like before and after diagrams and stuff like that.
And the more that you do, especially if you're coming up with creative ways of describing it, independent one, I look at that and I go, nice. See, because what I did in reading your essays, I read them all before I graded them. So I went through all of them and read what you wrote. And then I said, okay, who did better than others? How did you all line up? And that's what I would do. So if I saw somebody, and I'm telling you, this is true of any teacher in any class, make your teacher go, that's good, that's different. Man, you do something different that not everybody else does, they're going to notice you. I mean, hopefully good different. Be aware of that. Be aware of what people are expecting of you as a student, what we're trying to get you to do. So if you said, man, you could draw diagrams with different lapse rates. Yeah, it was really good. You could do that. I noticed that. You know, and then you look, and then if you make it neat, it also, do you know what neatness does to a lab? When you turn something in that's really neat.
Makes it easier to read.
It's easier to read, and then I'm happier, and then I overlook mistakes. You know, if I have to, what are you trying to say? And it's like, oh wait, that's not the right word. But if I'm like, oh, that's really good. Boy, that's really professional looking. I'm going to overlook mistakes. That's just the reality of teaching, just so you know. So the more time that you put into making it good, the better you're going to be in getting grades. So there you go. Any other questions on the lab? So can you get that done and make it a little bit better? Because I'm way behind on grading, and I'll probably regrade that from you. Your diagrams, there's another thing that I had a problem with some of your diagrams is you weren't very, and I get it, trust me, I get it. You're trying to draw things like I drew, but you're not aware of the differences. Do you remember the game that you used to play? What are the differences between this diagram and this diagram? You played that as a kid. You're like, what's the difference? Oh, this guy's wearing a hat, this one's not. You know, there's a belt buckle. That's what you need to be aware of when you're drawing your diagram versus mine. Make them the same so that you're careful with them. Lena, I think you made a couple of things when you were drawing the tropopause. And I don't know what you were referencing as the tropopause. The tropopause should be the coldest temperature that you get in the environment.
Okay.
based on my diagrams. It's technically not, but that's what you're thinking.
Okay.
So do you agree that thunderstorms should go into the stratosphere? They should go above the troposphere. They should go above the EL. Thunderstorms go well above the EL. Now, do me a favor. Get out in your notes. There's a little thunderstorm notes. And we're going to talk about this because I don't want to get into something completely new. So get out that notes. I'll share my screen. I can go here. I can go to academics, class notes, and I'm going to go unit 2 notes, and I'm going to go to this thing, thunderstorms. So when we understand this air mass thunderstorm, so we're going to, we'll do a little bit, and I teach an entire class on thunderstorms, and we do a lot. So I'm not going to get into it in this class, in intro, very much. So we're just talking about something that forms. It's usually non-severe. So Sam I'm going to start quoting Dr. Seuss because I'm kind of over the whole, anybody who thinks Dr. Seuss is a racist is an idiot in my book. I'm tired of
Too sensitive nowadays.
I don't care. I don't care anymore. If I offend you, tough. Be a person of strength. I'm so over the world. I can barely stand anymore, especially when I'm alone. So Sam, here's a question for you, buddy. Explain to everybody what I mean by this. That's a really big thing. Can you explain? Because I didn't tell them what it is. So can you explain what it means?
Yeah, we printed it in here.
What do you want me to explain?
Well, it says it's non-severe. I don't think they know what severe is. How many people know what severe means?
Okay, because when you drew over it, I couldn't see anything.
Yeah, so severe. Explain what severe is. What's a severe thunderstorm?
So severe means that it has certain requirements to be severe. And that is, so a severe thunderstorm is considered severe when it has hail the size of 1 inch or greater.
Okay, so I have a hailstone 1 inch. Do you know how big that is?
About a quarter.
It's like the size of a quarter, yeah. Or
winds that are 50 knots or greater, or 58 miles per hour or greater.
it's going to start to do some, like if you get a 50 mile per hour wind or 58 mile per hour winds, you're going to start knocking down some, I don't know, 2-inch diameter branches. Like you're going to do some damage to trees. What else would you damage? Maybe at 58. Shingles. Trampolines. That's always a big thing in the suburbs. Trampolines start flying. And then what else?
Or tornado, or has a history of producing a tornado.
Now, what kind of storms are most likely to be severe? Sam?
Supercells.
Okay, so there's a storm that's called a supercell.
I also wanted to say squall lines as well, because
they certainly can. And something though about a supercell, what's special about a supercell? It's what? It's blank.
Rotating.
It's rotating. So if I have a storm that's rotating, then that's what a supercell is. But to get rotation, I need something in the atmosphere. What do I need? Sam, one more question for you.
Need vertical wind shear.
I need vertical wind shear. Okay? Vertical wind shear. And vertical wind shear is what? Lena, how would you describe what vertical wind shear is?
Oh man.
In words.
I would describe vertical wind shear as like it's what tilts, isn't it what tilts the supercell?
I'm not asking about what it does. I just want to know what is. What
Is
when
it
I say
super
vertical
strong
wind
winds
shear.
in the
Explain-
atmosphere?
Yeah, explain to my class what vertical wind shear is.
Oh gosh, I would say vertical wind shear is winds that are like not at the surface. So where the cloud is, that causes the supercell to rotate. I'm so bad at this.
Anybody other than Sam? Anybody else know what vertical wind shear is? Have you heard of this term before? Well, actually, everybody, look down here. What is vertical wind shear? Can you read that? You all reading it?
It's the change of velocity with respect to the height of the storm.
So listen to me, Shannon. Everybody watch.
That's a question.
That's a question.
Well, how would I write it down then? Isaac, you remember? That's a question. And that says vertical wind shear is the change in velocity with respect to height. How would I write that down? Go ahead, Tim.
dv dt or dz.
dv
No.
dz.
Mhm.
How does the velocity change with respect to height? Now, show me with your hands what vertical wind shear, Sam, don't do it, Lena, don't do it. Show me with your hands what vertical wind shear looks like. Okay, Aaron, you are not right. And I can tell that you're not right because you're not using something. Oh, now you're getting better. Isaac, no. How about the rest of you? Show me vertical wind shear. Ryan?
I got no clue.
Well, the velocity of what?
The velocity of wind?
And that changes with height. Show me that.
Like this?
Okay, so you're doing this. Wrong. That is wrong. See, and the funny thing is, you guys are all doing stuff like this. You're thinking up. And that is not correct. What's changing? Start with that. What changes?
Oh, is it like this? Maybe?
Okay, that's wind. Make it different as you go higher.
Oh, it goes up and down like this, maybe?
Well, it doesn't go up and down. What would you have to use?
The height goes up and down.
Right, you go up. So don't you have to show wind doing something different at a different height? Isn't this what wind shear looks like? So you have to use both arms going in different directions. Do you agree that that's changing? Or maybe they're going the same direction, but at different speeds. Okay, so that is what vertical wind shear, because wind shear is the wind, which is horizontal motion. And the wind down here is different than the wind is up here. It's not that the air is going up. That's what a thunderstorm is, but that's not what we're talking about. We're saying that the wind is different as what goes up. You go up. You are going, here's the wind blowing this direction down here. And then I walk up a ladder and now the wind's going a different direction. This is wind shear. And it's funny, every time I ask students that, they always do this. They always move their arms up. And that's just, you're not thinking it right. Does that make more sense then? This is wind shear? Well, when there's wind shear, I want you to write this down. Vertical wind shear organizes thunderstorms and causes them to rotate or potentially rotate. That's what I want you to know. Now, look at over here. Hold on. Look at over here. These storms that we're talking about are it says air mass thunderstorms rarely produce destructive winds or hail because of the absence of vertical wind shear. So this is a simple situation where there's no shear. And when there's no shear, they're not organized, they don't rotate, and they're likely not going to be severe. So I'm just talking about some simple thunderstorms, and thunderstorms are basically a couple of things. We'll talk about it. In fact, I'm going to give you this information. Why don't you write this down? Can you write this down for me? Kevin, you okay with me just like dictating? Are you typing this out or writing it out for
Just
Aaron?
writing it.
Okay, so let's do this. A thunderstorm is more of a process than a thing. It is warm air rising.
Could you slow down?
Oh, yeah, I'm sorry.
Okay.
It is warm air rising and cold air sinking. And the reason I want you to know that is because I want you to circle this information and start, because at some point I'm going to ask you about that statement. But what is a thunderstorm in your mind? It's a big cumulonimbus cloud, right? It's a cumulonimbus cloud, and it's warm air. That makes sense because the parcel's what? Warm air rising is because the parcel is what?
Unstable.
Is unstable, right? That would be a fine answer. Now, if the parcel is unstable, what can we say that the atmosphere must be?
Colder than. It must be colder.
No. If the parcel is unstable, then the atmosphere must be what? This is a kind of a review just to make you see this. Remember we said when I'm dealing with the layer of the atmosphere or a layer of the atmosphere, what are the answers to the question of its stability? It's either what?
Oh.
Isn't it absolutely stable, absolutely unstable, and conditionally unstable?
Right. So if I have a thunderstorm, what does the atmosphere have to be?
Absolutely unstable.
It could be. That doesn't happen very often. So it has to be at least what?
Conditionally.
It has to be at least conditionally unstable. So I have warm air rising. And that's true because the parcel that I imagine things with is buoyant. It's unstable. And we say that we're going to get thunderstorms when the atmosphere is at least conditionally unstable, which means if we get it saturated, we can make it unstable. That's what that means. Okay. And when that happens, parcels go up. And as the parcel goes up, we have this going on. We have a cumulonimbus cloud. It is puffy. It is going up. That is that. And when the air is all going up, we say that's a certain stage. And that's the cumulus stage of a thunderstorm. So it's cumulus, it's going up, warm air is rising. And it says it starts with the warm plume, a flow of rising air. Now, it says the updraft velocity increases with height, which means this warm air starts going faster and faster. It's increasing in its velocity, right? It's accelerating upward. And as a result, and we'll see this later, I'm not going to deal with it too much at this point. That's going to pull air from outside the cloud in. So air comes in from outside the cloud. That process is called entrainment. Okay. Now, what do you know about the entrained air? There's 2 facts you should know about entrained air.
Is it cooler than the air inside?
It's cooler than the air inside. That is one.
It's not saturated.
It's not saturated, right? So it's drier. So we know it's cooler because it's an unstable cloud. And we also know that it's drier. In other words, what's the relative humidity of this air? It's not saturated. It's less than 100%. What's the air inside the cloud? RH is 100% inside the cloud. Yep, okay. Now, the next sentence, the next bullet point says, supercooled water droplets are carried far above the freezing level. Now, you should have done this in your worksheets. So what does that word mean? Do you know what supercooled means? Have you read about it yet or done the outlines of this yet? The worksheet. Is that due this? What's due on Monday or Sunday night?
Chapter 5 reading assignment.
Chapter 5 reading assignment. Have you done it, Isaac?
I've looked over it. I haven't started it yet though, but I was going to do that tonight.
Oh, okay. Lena, have you done it? I mean, it's fine. You haven't done it. It's not due. Have you done it? Does
Yeah,
it have
I've done
super
it.
cooled in there?
So I'm pulling it up right now to see. I don't feel like I remember seeing it.
Maybe it's in the next chapter. Maybe we're ahead. I have no idea where we are. We're kind of going to different places because it's fun. That's what I love about small classes, is that you just kind of go with it and you learn stuff. And right now you're making me happy. And what did I tell you about happy teachers?
Grade better.
I grade you better.
Yeah,
But just know that when you're here all the time and I look at your face and I'm seeing you always participating, I'm not going to cause you to get bad grades. I'm going to try to help you with good grades. So you do what I want you to do. I get happy and give you better grades. Okay. So
I just looked and I found that supercooled water is in chapter 7.
is it in when does chapter 7 due?
The week after next. So like this Monday is chapter 5, the 7th, and then chapter 7 is due on the 14th.
Okay. If you could do chapter 7, that would be great. But here's the deal. We're going to be getting into chapter 7 next week. So super cool. What does it mean? It just means that water is below freezing, but it's still liquid. So if you want to just think that super cool water is below freezing. What's the freezing point?
32 degrees Fahrenheit.
32 degrees Fahrenheit. What is it in Celsius?
0.
So we still have liquid water below that point. That's super cool. And we'll reference this next week. So I wouldn't worry too much about it. Okay, so that's what's happening in this stage of a thunderstorm called a cumulative stage. Now, what happens when we go to the next stage, the mature stage? What's the onset of the mature stage? It starts to rain. So once the air goes up, now it's going to eventually go down. Okay, it's going to start to rain. And what that does is the rain itself pulls down air with it. So it's called frictional drag. The raindrops fall because they're heavy and gravity's going to pull them down. The air itself starts to come down as well. Okay? Now the next sentence says, evaporative cooling leads to negative buoyancy. So what do I mean by this first 2 words? What's happening? Or what must be happening if I say evaporative cooling leads to negative buoyancy? It's a simple question. It's actually a simple answer. I said there's evaporative cooling. What's evaporating?
Water.
Well, yes. What water, though? Key thing.
The cloud itself.
Is it the cloud itself? What do you think? Do you think that that's the answer, that the cloud itself is evaporating? What do you think?
I don't think so.
I mean, the rest of you can say, I think that's what it means. What do you think? If you say no, then what do you think is evaporating? What's your thoughts here? What do you think, Aaron? What's evaporating?
R-A-I-N, the rain.
Oh, okay. So is it the rain or is it the cloud that's evaporating? What do you think? What do you think, Julia? Zach, you just had a moment.
So we're getting higher into the atmosphere, so the temperature will be decreasing. So would that mean the capacity of the cloud is like the cloud is dissipating, right? Or
Well, okay. If you say the cloud is evaporating, is that a possibility?
well, the cloud is liquid water, right?
Okay, kind of that smart ass comment is kind of what I was hoping somebody would say. I mean, if you're going to have something evaporating, what evaporates? Liquid water. Isn't a cloud liquid water? Couldn't a cloud evaporate? And the answer is, well, yeah. And why is the cloud evaporating? Two reasons that you could have evaporation of the cloud. Look at the picture.
Temperature.
What do you mean?
Because it keeps going up and up. That means the temperature's decreasing.
Well, that's okay, because as the temperature goes down, right, the air is cooling. That's fine. You can still be saturated.
Yeah, but if the temperature is decreasing with height, that means the capacity for saturation decreases, and then some of the air has to be evaporated. Or not the air, the water.
Because the colder you get, it's just like going up over a mountain. You still have that saturation. But what kind of air are you bringing into the cloud?
Dry air.
Well, wouldn't that dry air, if you brought dry air into a cloud with 100% relative humidity, wouldn't that cause the relative humidity to go down? And that means you're evaporating the cloud. Clouds can only evaporate when the relative humidity is less than 100%. So the question is, why would some of the cloud evaporate? Because I'm mixing within it dry air. But do you remember we said that the cloud was the box of air? And what kind of a box is this?
Vegas box.
Vegas box. And we said the Vegas box says the air in the cloud is the air in the cloud, and the air outside the cloud is outside the clouds, and we don't allow it to mix. But do you understand that in real life, in reality, air does mix? So the cloud can evaporate when it mixes with drier air. And that's where the partial theory stops working. It fails at that point. Does that make sense to you? So entrained air can cause the cloud to evaporate. And evaporation results in what?
Cooling.
Cooling. So that cool air is negatively buoyant, which means what is the air going to want to do when it's cold? Come down. But now Aaron said, well, some of the raindrops might evaporate. Well, where in this picture, will the rain evaporate?
Is it wherever the dry air comes in?
Okay, I'll have to give you that answer because that's a good thought. For now, let's imagine that the cloud is 100%. Well, the raindrops evaporate in the cloud. Whereas the only place then that the rain is drawn, that's not in the cloud,
Underneath it.
underneath the cloud. But as the rain falls through air that's not in the cloud, do you understand that that rain will evaporate? What temperature is the raindrops trying to make it? Isn't it the wet bulb temperature, the temperature of a raindrop? So the rain that evaporates is going to cause cooling below the cloud, and that cool air is going to do what when it hits the ground? If it comes down, what's it going to do when it hits the ground? It's going to have to spread out, isn't it? And that's what you feel when a thunderstorm comes by and it gets cold. You feel that flow of cold air. But it's the cold air that you feel from a thunderstorm is because of evaporation. Does that make sense to you? So this thunderstorm is the first time that we start realizing that real life is not theoretical parcels where we don't allow mixing. Real life mixes, and it makes it more complicated. Okay? Is that good for everybody? At this point, where does the top of the cloud start to approach? The tropopause, and it forms the anvil top. Now, reality is it starts to approach the EL, which is usually, it can be above the tropopause. Does it go beyond the tropopause or the EL?
Yeah.
Yes, it overshoots it and comes back down. But the anvil top, what cloud is the anvil? What kind of cloud is the anvil?
Is it cirrus?
Cirrus. Cirrus is made of what? Ice. So everything in the anvil is iced, and the anvil forms at the EL. Okay. Now, when that happens, what's next? Then we go to the next stage where it dissipates. The downdraft takes over the entire cloud. There's no more air going up. The storm doesn't have this supersaturated updraft air. We'll explain. What do you think supersaturation means? What do you think supersaturation means?
Is there more water inside of a cloud?
Here's something interesting, right? What RH? RH is, it contains the amount of vapor that it can when it's saturated. It's holding as much as it can. Supersaturated means the relative humidity is greater than 100%, which doesn't make any sense. How many people can a theater fit? As many people as I've got seats. Can I super fill a theater? I guess the answer is yes. I can put more people in there than I can actually have in there. So the atmosphere has more vapor than it really should have. That's supersaturation. And that's a concept that's a little bit confusing. That will make sense in chapter 7. So we're going to get to that a little bit more. But once the air is no longer going up, do you understand I have no reason to make rain? So the precipitation decreases, and then what does the cloud eventually do? It evaporates, dissipates, it goes away. It mixes with the air around it, and it goes. These 3 stages are the stages of a single cell thunderstorm. Takes about 30 to 60 minutes. So here's the test question. What are the 3 stages of a thunderstorm? And you'd say cumulus, mature, dissipating. Why are these thunderstorms not severe? There's no vertical wind shear. What does vertical wind shear do? It causes them to organize and rotate. That makes storms more likely to be severe. What does severe mean? 1-inch diameter hail, damaging winds of 58 miles an hour, or tornadoes. So this is just basic stuff in a thunderstorm. But do you see how it puts together a lot of information? The only part of this that we don't understand is the idea of supercooled and supersaturated. And that's how we get into precipitation processes. So let me go backwards. And there is stuff in here about cloud types. I can finish up cloud types in 10 minutes. I've already told you some. What are the two basic types of clouds? Stratus, cumulus. You could say cirrus, which is ice. The rest I can do. I'll do that with you when it's fun. The next thing is this thing called the Bergeron process, which talks about, well, how do we get precipitation? So I want you to study this up and maybe look at chapter 7 for next Tuesday. But if you don't have time, that's fine. I'm not going to go crazy if you can't get chapter 7 done. However, and I've already given you this. Did you see that I put a due date on this lab? Where are we?
Is it a geography one?
The geography lab.
You did it. Okay.
So on the geography lab, right, here we go. That is going to be due Sunday night. Now, some of you have already turned it in. How many of you have done it? Aaron, you did it, I know that. Isaac, you've done it. And Lena, how did it take you a long time? It was pretty straightforward, right?
Yeah, I definitely made it longer because I did it online for the map, but
okay. So you guys are good. You should be able to get to, and you've already looked at, chapter 5, so do chapter 7. You're ahead. Great. The rest of you, I got to get this thing done from you. Has anybody else started it? Hold on. Who started it?
Started which?
The geography lab? Well, you're finished, Kevin.
Yeah.
You guys are done. Have you started it? Okay, well, it's due.
Okay.
Yeah, I signed it a while back, a couple weeks ago, so you're just not working ahead. So I'm not concerned about you. I'm not crying those tears. But you should, Isaac, it was pretty easy to follow the rules and just do it yourself, right? Okay, so that's fine. So everybody good what's due this week? You have to turn in chapter 5 outline or worksheet and the geography lab. If you can do chapter 7, you'll be working ahead. Next week, we'll work on the final stuff in this class. And then toward next weekend, we'll start to assign the test. I don't know when the test will be, but it'll be like last time. I'll give you some time period that you can take it in. Fair enough? Okay, greenhouse effect, 1 to 5. How do you feel about your knowledge of the greenhouse effect global warming? I've got some 4s and some 5s. Good. You improved today, I hope? And you know what it is? Just so you know, if you ever enter a discussion, you know more about defining the greenhouse effect and global warming than 98% of the people out there talking about it. So good for you. How did you do on the thunderstorm stuff? That's pretty easy. That makes sense. And how are you doing on the instability stuff? You've got plenty of assignments. You've turned them in. I think you guys are doing fine. So everybody good on what you got done? Okay, well, listen, you guys are, like I said, I love this class. I love the fact that your faces are here. I actually like your faces. Everybody but one. There's one face I don't like in here.
I'll shave. I'm sorry.
Is baseball season starting on time?
I mean, they're still in spring training.
But I mean, is it going to start in the end of March and April?
I think so.
Oh, see, that's the beginning of spring. So we're almost at spring. Have a great weekend. Go. You have one more assignment to do. And that is for at least a half an hour, go enjoy the weather when it's warm this weekend and sunny. Go walk your dog, okay? All right, guys. You have a wonderful weekend. We'll see you on Tuesday.
Thank you.
Bye. Have a good day. Have a good weekend.
Tuesday.
Bye.